Good day, my name is Bernice Hickman and today I will be presenting to you my Technology Futures assignment. The topic of the assignment was derived by first of all creating a messy picture of an array of topics revolving around artificial intelligence, commonly known as AI. Through the process of creating this information, it was clustered and various nodes of interest were identified. The nodes that will be covered in this talk will be the node around AI as an innovation, the evolution of AI, as well as the human response to AI, and culminating in approach to responsible and trustworthy AI. The lens that we're casting here is a technology futures lens looking at the convolution of AI and humanity. Let's start with sci-fi as one of the most accessible lenses to a possible future. Looking at ScreenRant.com, they list the top 10 sci-fi movies in their opinion. I have been through most of these, and what is actually quite interesting is that 9 out of 10 of these movies show the interplay between humans and AI being somewhat problematic and mostly going quite pear-shaped. These dystopian views create perceptions and fears in humans about what the possibilities of AI may or may not be and the consequences for humanity. In fact, the only movie out of this list that was somewhat utopian is WALL-E, a movie that is easily relegated to being a kid's movie. Andrew Ng, who is a leading practitioner as well as scholar on the topic of AI, refers to AI as the new electricity, in that AI will transform the production line of businesses in pretty much the same way as electricity did in the past. His rule of thumb is that anything that a human being can do with thought processes taking about a second can be emulated and reproduced by AI. Now, one would think that not a lot can be done in 1 second, but most of the tasks that AI can reproduce are actually a series of sequential 1-second thought processes and tasks currently performed by humanity. So when did AI actually first start to threaten humanity? AI has been around for a very long time. Homer referred to it between 750 and 1200 BC in his writings about an automaton type of machine that could assist in serving the gods. In 1670 AD, Gottlieb Wilhelm Leibniz and Blaise Pascal actually started working on mechanical reasoning machines similar to what we might refer to as calculators. In the first industrial revolution, mechanization was very important. This is nothing more than machines reproducing the tasks and replicating the tasks of humans and animals to make things more efficient. By the time we got to the third industrial revolution, mechanization started to evolve into digitalization, where it was not just the mechanical functions of humans that were replicated, but also some of the cognitive functions. At this point, it probably started to become apparent that machines had the possibility to outdo humans in terms of job efficiency. Moving forward into the fourth industrial revolution, the exponential pace of change started to overwhelm the cognitive ability of individual humans. Interconnectedness, smart automation between machines, this became the first time that humanity started to wonder whether machines could actually outthink them. We're now moving into the fifth industrial revolution, and this might present some hope for humanity because this revolution revolves largely around a consciousness of the impacts of technology and humanity and how these things intertwine specifically as well in our environments and habitats. Planetary protection, those types of topics come to the forefront in this revolution. So can a machine really think like a human? There are many different types of artificial intelligence depicted in this circular diagram. What is, however, apparent if you look at the AI of today is that most of the truly functional AI that is becoming mainstream still involves the supervised learning of artificial intelligence models. That doesn't mean that in the future we will not have unsupervised mainstream models. There are models such as deep learning models that use complex neural networks, and the processing power would overwhelm most of traditional algorithmic models. Transfer learning is another technique which is at the emergent stage at the moment, where one model can actually learn from another. And unsupervised learning involves models that can figure things out for themselves without us creating heavily structured and tagged labeled types of data sets for them to use for processing. At this point, the abilities of artificial intelligence will increase exponentially. However, viewed on a typical S-curve, we would find that the supervised learning models of AI have already been through their hype curve phase. They've already gone through the trough of disillusionment, referring to Gartner's terminology, and are now approaching mainstream utility in many aspects of industry, commerce, and our daily lives. The unsupervised AI models are arguably still in the trough of disillusionment as businesses try to figure out how to create scalable and usable, practical use cases for these types of models. The levels of complexity are probably such that these have a while before they become truly mainstream. So how does a model actually work? I've used a very simple example over here. A model that would predict when will I drink red wine. Now, there are three main variables that I've injected into this model. The one is I'm eating, I'm busy having a meal, it's raining, and I'm not working tomorrow, so I'm not really worried about the after effects of a glass or two. If we take these three variables, now we plot them and we realize that there are a number of different scenarios in which these variables can interact. Also, these variables are not equal and important to me. So in the center of this model, you will see that there are various weightings that can be placed on each of these variables, as well as each combination of the variable. What will then happen is, in a certain weighted pattern, the model will generate an outcome, which will be a yes or no answer about will I drink wine tonight or won't I? Now, the first answer that this model provides is probably not going to be the correct one, because it will probably assume that each of these variables are weighted equally. I am, however, a complex person, and I do have different weightings of these variables depending on certain circumstances. In a supervised model, I would then explain to the model, no, actually tonight I'm not going to drink wine, and it would learn, understanding, and would add variables to it, understanding how might these weightings change under a different set of circumstances. There's also a very important other aspect to always keep in mind in models, and that would be biases or distortions. Biases are things that are not always obvious or disclosed in the model. For example, if I were a functioning alcoholic, I probably wouldn't easily disclose that. But the fact that this actually is a variable that does exist could have a market impact on this model. So you will see that under the hood of this, it isn't actually magic. It's just very, very useful and somewhat complex maths as you add more and more variables and more interplays. The other thing to remember about these models is, because it is modeling my behavior and predicting my behavior, I am not a static person. I change my tastes in what I might want to drink with my dinner. So models that are not permanently learning, or at least maintained and overseen, could become brittle and degrade over time and lose their utility. This is a very simple way to explain what is going on under the hood of an AI model. Now what we need to turn to is how similar is the decision-making of a human to that of an AI or a machine learning type of model. The The first thing that we must understand is that the inputs into a machine learning model are through sensors or nodes or algorithms, but these are nothing more than numeric data points. A human, however, has a complex combination of sensory inputs going into our brain. We touch, we taste, we smell, we feel. And these are the types of inputs that go into our learning centers. If this had to be very, very simplified, what you would find in humanity is that if you found a person that was very passionate as well as very intelligent, you might predict that the motivation that comes with passion, as well as the ability that comes with intellect, would make the human very successful. However, psychology has taught us that if passion is not at least moderated with a degree of empathy, passion could become very overbearing of the wills of other people. And if intelligence is not moderated with an element of judgment, lived experience, and wisdom, it could become very academic and clinical, and sometimes not at all practical. Now, it is the empathy and judgment in humanity that is most amplified by our sensory intake and our lived experiences. So while both humans and machines have things like spatial awareness and can balance different inputs, the types of judgmental and empathetic responses you can get from a human are very different to what can be replicated by a machine just on pure algorithmic and numeric type input. It must, however, be noted that if a human being did not have the ability to moderate passion with empathy and intelligence with a form of judgment, that does start to manifest in largely antisocial behavior. So the parts of humanity that are most easily replicable in AI type algorithms, being the passion and the intelligence, could result in very, very antisocial and even sociopathic responses from the AI entity. So now looking at it, we see that the risk of machines becoming human is not as great as we might have thought. The question is, does the risk run in the opposite direction? Is there a risk of humanity becoming more machine-like? Let's first start with understanding, what is an android? An android is a humanoid type of machine. It functions like a human. It has jointed limbs and physiology like a human. And some of them resemble humans incredibly closely, even with the external synthetic makeup of the machine. There have been a number of examples in recent history where androids are so similar to humans that they have been mistaken. Technology is evolving to such an extent in bioscience that it is possible for humans to replace malfunctioning limbs or parts with prosthetic parts. Even internally, the science to print 3D organs and to ensure that the body can actually assimilate that organ without rejecting it is growing exponentially. Even the technology to DNA splice a human being prior to birth into a manifestation that is more desirable than potentially what nature would have provided for, that technology is also currently improving at an exponential rate. The question that we have to ask, however, is at what point do we become more android than human? At what point are we more physiologically a machine than we are a human being? And what does that do to our identity as a human? Looking at it from a cognitive development perspective as well, with the advent of IoT, we are finding more and more of human cognitive functions actually being performed on our behalf. IoT devices such as cell phones are just becoming an extension of what we are. Our text messages are automatically auto-corrected. Our thoughts are learned into these algorithms to the point that these are no longer just spelling corrections. The ability to move from text to voice makes writing redundant. Generative AI can create any type of imagery that we want, including the filtering and morphing of our physical appearance in digital mediums. We have instant access to almost everything via the web, and Web3 is going to allow us to simulate our decisions before we even have to make them in the real world. Social media all but governs relationships, with more and more of the relationships actually being more prominent in the digital world than they are in the physical world. Work from home situations are causing us to have to modify the way that we process our interactions. These are no longer highly sensory interactions. It's pretty much like we're working in a sensory dulled bubble. And so less and less of the sensory stimulus that we used to rely on for making our empathetic and judgmental decisions are actually being fed into our brains. At what point will human cognitive processes actually be invisible or entirely missing? Because most of our thinking is done for us by the machines that we carry around and cannot leave for a moment. More importantly, how should cognitive sciences evolve as AI becomes exponentially more competent? Finally, we have to go back to the simple model of humanity presented and ask ourselves, how would we be functioning when most of our decisions are either driven or at least suggested by the artificial intelligence that has become an extension of ourselves? If most of our decisions are driven by the artificial intelligence that we use as an extension of ourselves, what is the impact on human morality? And what is the role of conscience that used to be driven by our empathy? The negative psychological impacts of social media are already playing out and showing how these artificial intelligence biases could actually impact our relationships, our feelings, and our very state of mental well-being. Human rights are constitutionally protected. We have a very advanced constitution in South Africa, and listed here are just a number of the very important human rights that are protected under this constitution. Our equality, our human dignity, our right to life, freedom of expression, education, not being subjected to slavery, housing, parental care for children. These have always been held as highly important human rights. The question is, at what point do human rights actually become android rights? If humans are evolving to become largely machine and physiology, largely driven by artificial intelligence and thinking, at what point do these human rights even make sense? Here are a few examples to consider. In sport, at what point does the replacement of a limb through a prosthetic device cease to be classified as a disability and actually become a point of heightened enablement? These are difficult decisions to make, and we've seen a couple of case studies playing out. Most of them have been outward prosthetic. What happens when it becomes inward prosthetic and truly performance enhancing? The right to compete as a human will need to be questioned in sport. The right to medical care. At what point do we look at a human and decide whether most of that human being is actually just there for maintenance or performance enhancement, and which part is there as a right to life and existence? How do we apportion government funds for medical access in a fair and equitable way? Freedom of speech. What is freedom of speech when most of the information being fed to us is algorithmically driven and prone to bias? Is it really our freedom of speech when we are being subconsciously fed concentrated pieces of information designed to focus our attention, our thinking, and our psyche in a certain direction? Recent advents in politics in the United States have shown how possible this actually could be. Intellectual property and patents. When information is so readily accessible and a lot of our decisioning, thinking, and suggestion is being driven by artificial intelligence and machines, what part of information is actually ours? And what part of it was actually suggested from innovations that were derived way out of our line of sight? Relationships. If our relationships are largely virtual, what happens to marital rights? What happens in the case of divorce? Where do physical assets and digital assets actually collide in terms of the rights of spouses? These are just a couple of examples which show how complex life can become when humanity and artificial intelligence, machine technology start to converge. But this should not be a dystopian view. The fact of the matter is artificial intelligence is a magnificent technology. It's with us. It will continue to evolve. We have reasons to be greatly optimistic on how it can enhance and improve the daily lives of people. What we need to understand is that humans drive the machines, for the moment at least. The machine does what we tell it to do. At points, because of our cognitive limitations, we may not always understand what it is that we are telling these machines to do. And this is where it becomes important for us to understand that whatever we do with technology needs to be done in an ethical and trustworthy way. Innovation will always run faster than regulation. That means that these types of technologies have a propensity to be fully and truly unregulated for a substantial period of time until they become truly mainstream and understood. It's also important to understand that the knee-jerk reaction of regulation would be to curtail before it is to enhance and enable. It means that it places a business on people who embrace and embed AI into the daily lives of their business, into helping and providing better services to humanity, to do so with an ethical and trustworthy lens. In conclusion to this presentation, I've worked through a framework and put together a couple of key themes which show the types of considerations that organizations that employ AI should have in an ethical governance framework. We should be preoccupied with the fairness of the model, minimizing discrimination and bias. We should worry that our model is robust and reliable and not rendering incorrect results. We should worry that the model is transparent. Both the users of the technology that may have AI embedded in it, as well as the clients, have the right to understand that they are interacting with artificial intelligence type technologies. The decisions that are made by these technologies should be as traceable as possible. There are deep neural network models that are somewhat opaque, but tooling to understand, at least on an after-the-fact basis, how conclusions are reached is also evolving just as fast. And it is important that model designers incorporate these types of tools. The security of the model is important. It uses vast amounts of data, but the data remains the personal and private property of the consumer it refers to and needs to be appropriately protected. The ethical standards that are put into AI need to be considered in terms of a broad-based standard of values and harm. We should seek to make sure that we understand whether there are psychological, economic, environmental, legal, or human values harms that could be created in the deployment of a model, and take the necessary steps to mitigate these risks. And finally, we need to understand that the responsibility for the deployment of AI models does not lie purely in the data sciences and technologists who develop these models. It is up to the leadership of organizations to understand how these models function to the extent that they can make proper, just judgmental decisions on how they are deployed in their businesses. This responsibility cannot be abdicated. Looking to the future, this will probably become a King 3 type standard of obligation to business leaders and board members. And it is important for us to understand and embrace that responsibility now as AI continues to evolve. In closing, it was Steve Jobs that said, technology is nothing. What is important is that you have faith in people and that they're basically good and smart. And if you give them tools, they'll do wonderful things with them. It is important for humanity to understand that change will happen. It doesn't matter if we understand it or whether we don't understand it. It is still going to happen. It's important for us to be clear on how humanity and technology can combine and create a better life for all in an ethical and trustworthy fashion. In closing, I'd like to spend some time on reflecting on my Technology's Futures journey. In doing this assignment, the first thing that I had to do was a vast amount of scanning, so much reading. I have read books, I've read journals, I've read articles, and I must just say that each one was fascinating and sent me down a different path. To put all of this together really created a truly messy picture. I even watched some science fiction movies, and I'm not a movie person, I'm definitely a reading person. The messy picture was an experience in itself. At one point, it just felt like I was completely overwhelmed with the different threads and the different topics. This is truly, truly a vast subject. However, in putting the data down into this picture, eventually the nodes that were presented in this presentation emerged, and I could set the boundaries of the missing picture and create a central idea. The idea that humans are fearing machines, but actually that the risk might be in reverse, in that we are becoming machines, was a very interesting thought to me. And I spent a lot of time observing how many people rely on the decisions of AI to get through their daily lives. It became very clear to me that if humanity is at risk, it's actually us that are putting ourselves at risk. In analyzing all of this information, I went back through the classes and the interactions that we had in class, and I had to go through many iterations of following threads, deepening my understanding, coming back out, reconsidering my nodes, summarizing. I have to say that the class interactions and the practical way that we spoke about those topics definitely helped me to not become overwhelmed. Those experiences were invaluable. Finally, the refinement and application of the topic. I found it very difficult to refine all of this content into a very succinct 15-minute storyline. And getting to the so what to become a workable action plan. It has, however, been entirely gratifying to be able to come up with that framework, as well as use this content to explain to stakeholders in my business how AI might function and to create a shared understanding of its potential as well as its risks. I can say that that framework is at the moment being test-driven in my business by our data scientists and model deployers, and is also creating the ability for us to actually share the understanding of AI to other stakeholders in creating an awareness of their responsibilities and accountabilities as well. All in all, for me, it definitely has been time well spent on this module. I thank you for the journey. I thank you for your input. I thank you for the enrichment that you have created for me and my business.